Welcome back to the deep dive. So if you've ever watched a toddler transform from, I don't know, a small, slightly confused ball of energy into a mini person.
With opinions.
With lots of opinions, demands, and this surprisingly strong empathy. You know, you're witnessing something like magic. But today we're diving into the science behind that magic.
The architecture of the young mind.
Exactly. Specifically during that critical toddler phase. So ages 1 to 3. Our source material for this is it's rigorous and really fascinating. We're unpacking research prepared by the Human and AI Learning Institute, the HALE Institute.
And the paper is called Parents' Role in Building Toddler Cognition and Understanding.
And that title really frames the whole mission, doesn't it?
It does. I mean, this research completely rejects the idea of passive caregiving. It makes a really rigorous argument that parents aren't just raising children, they're active architects.
Active architects. I like that.
Yeah. And our mission today is really to uncover the dual role these architects play. You have the scientific role of building the brain's raw capacity, and then this more philosophical or ceremonial role of integrating all that capacity into a meaningful life.
Okay, so let's unpack that central split right away because it seems to drive the entire paper.
Yeah.
The research draws a very clear line between cognition and understanding. They're presented as separate, vital developmental goals, and you need both to, I guess, build a whole human.
That's it, exactly. So the HALE Institute defines cognition as, the raw processes of the mind.
Like learning, memory,
problem solving, symbolic thought.
Yeah.
It's the functional hardware, you could say. The engine of the brain. The paper has this great visual for it.
The river of thought.
The river of thought, yeah. The actual mental flow.
The ability to just think and recall and categorize things.
Mm-hmm. But understanding is different. It's the integration of meaning that you get from those cognitive processes.
Okay.
It's the bridge, really, between raw data and the real world. So it shows up as empathy, a sense of self, and the ability to, make meaningful connections. If cognition is the river,
then understanding is the bridge across it, connecting the self to everything else.
Precisely. And that's the high wire act of being a toddler, from ages 1 to 3. They're moving from just basic sensory exploration.
Tasting everything, touching everything.
Right, into fully formed symbolic thought. So they're building the river and trying to construct the bridge at the exact same time.
Which creates huge demands on the architects, the parents.
Immense. Think about a simple task, like building a tower with blocks. The cognition part is assessing balance, stacking the blocks, using trial and error so it doesn't fall. That's just pure process.
But the understanding comes in when the tower collapses, or, when another kid wants a block.
Exactly. The cognitive process fails, which leads to frustration. The parent, the architect of understanding, then steps in, not to rebuild the tower, but to introduce meaning.
So you'd say something like,
"You're frustrated because your effort didn't work. We need patience, or we can try again." Or maybe, "That block belongs to your friend. Sharing means we still have fun, but together." That moment turns that raw processing into integrated social meaning.
That brings us right to the developmental timeline, which gives us some context for all this furious building activity.
It's a nonstop acceleration, truly. You see the early groundwork laid at, 6 to 9 months?
Recognizing names, cause and effect.
Yeah, the basics. But once they hit that 12 to 18 month mark, the whole game changes. You see the real start of symbolic play, pretending a banana is a phone.
Right, and they can follow simple instructions.
And then you get that famous rush from 18 to 24 months, which the paper calls the little scientist in the lab phase.
Love that. That's the vocabulary explosion, right?
That's it. They might be learning dozens of words a week, and it's combined with this systematic trial and error learning. And by 2 or 3, it's in full bloom. Imaginative play is robust. They can handle multi-step problems.
So you've got this incredible, almost predetermined timeline of capability, which leads us to that classic puzzle, nature versus nurture.
Mm-hmm.
The HALE research spends a lot of time on genetic potential.
They're very clear on this. Genes provide the fundamental blueprint, but definitely not the final structure. We're talking about polygenic inheritance here.
Meaning many genes are involved, not just one on-off switch.
Exactly. They cite examples like the FOXP2 gene for language or BDNF, which helps neurons grow and connect.
So if cognition is polygenic, it's highly flexible. But, does the paper suggest that genes set a hard ceiling for cognitive development?
That's a great question. And the paper actually kind of pushes back on that strict ceiling idea. Unlike a fixed trait like eye color, which is determined by a few genes, and that's that.
Right.
These complex cognitive genes provide more of a range of potential. The environment doesn't just push the child up to some set limit. It actively influences whether those genes get expressed optimally.
So a good environment could help a child reach the higher end of their genetic range.
Or potentially even raise that range through sustained, meaningful input. The environment isn't just decoration. It's a co-creator of the outcome.
Absolutely. So let's talk about behavioral traits. We see toddlers with these intense characteristics that feel so inherited, like stubbornness.
Oh, definitely. The paper notes that the tendency towards strong will or certain interests is partly inherited.
But then how does the architect step in? I mean, how do you take raw inherited stubbornness, which can just look like defiance, and turn it into something positive, like persistence?
Well, that's where the architecture really matters. If that stubbornness is only met with rigid control and frustration, it expresses itself as, defiance, lack of cooperation.
Right.
But if the parent, through that ceremonial role we'll get to, guides that stubbornness by saying something like, I see you really want that, let's redirect that effort into finishing this puzzle, then that trait gets sculpted, becomes persistence, focus, drive. The environment shapes how the inherited trait is expressed.
That's a key connection. Okay, let's move to the practical applications. The first half of the parent's job, the scientific role, building that pure cognitive machinery, the river of thought. What are the key actions here?
These are the observable, measurable inputs. And first up is language exposure. The research is clear. It's not just about having the radio on.
It's about quality, not just quantity.
It's the volume and the quality of interactive talk reading, telling stories, responding. This kind of accelerating exposure builds the actual structural architecture for complex thought.
So if a parent is talking to their child using varied vocabulary, what's the measurable difference the Hale research finds compared to a low exposure environment?
The differences are stark, especially in the density of synaptic connections in the brain's language centers. It really reaffirms what we already knew. Kids in these high-quality verbal environments don't just get bigger vocabularies earlier.
Right.
They also develop better executive function skills. The brain just has a more robust infrastructure to organize complex thoughts.
The next key action they list is providing that safe lab environment. Play and exploration.
Yes, the parent's job is to create a stimulating environment that, it doesn't just babysit the child, it has to encourage problem solving. So, safe spaces where exploration is the norm, not the exception. The goal is to let the child test their own hypotheses without catastrophic failure.
And crucially, the paper stresses modeling curiosity. You can provide all the toys in the world, but if the parent isn't engaged in learning themselves, the lesson is lost.
Absolutely. Modeling persistence is huge. If a parent is building something and they get frustrated, how they handle that.
Taking a breath, trying again.
Taking a breath, trying a different approach, even just vocalizing the thought process, that provides a template for the child. The child observes how to learn, not just what to learn.
Which sets the stage for persistence, and that feeds right back into turning that stubbornness into a positive scientific trait.
It all ties together. And of course, we can't forget the foundation of all of this. Nutrition and health. All this complex architecture, this rapid brain growth, it all requires adequate nourishment. You just can't build a skyscraper on a cracked foundation. It's the non-negotiable scientific requirement.
Okay, so once we've built the hardware, the river of thought, we need the operating system, the user manual. Let's shift to the ceremonial role building at that bridge of understanding.
Yes, so this is about meaning, empathy, social awareness. This role deals with the child's identity and their connection to the world.
Right.
During this period, the child hits these pivotal milestones, recognizing emotions in others, understanding that I am separate from you.
And starting to absorb the rules of the community.
Exactly. This is where the seeds of morality get sown, that earliest sense of right and wrong, which is dictated by parental guidance.
So what does the ceremonial architect actually do? The first point in the research is emotional mirroring. What does that look like when a toddler is, melting down?
Emotional mirroring is basically validating and naming their internal experience. So when a 2-year-old is having a total meltdown because their cracker broke,
a world-ending event,
a total catastrophe, the cognitive input for them is just chaos. The parent steps in and provides the meaning. So instead of just distracting them, you use language to process the feeling. Your cracker broke, and that makes you feel very, very sad or very angry. That is a big feeling.
You're giving them a dictionary for their own emotional landscape.
You are. And this teaches them that feelings are manageable, they're comprehensible, and that their core caretaker sees them. That secure foundation allows them to later recognize and manage those same feelings in others, which is the basis of empathy.
Next up, social scaffolding, which sounds incredibly academic, but it seems like one of the most critical parts of this role.
It is. It's the active teaching of cooperation, rules, sharing. But it's done in a very specific way. Scaffolding means you only provide the next necessary step of assistance, and then you back off.
Okay, so give me an example.
Say two toddlers are fighting over a toy truck. The parent doesn't solve the fight by just taking the truck away.
They don't solve the whole problem for the child.
No. They might intervene by scaffolding. They'd say, trucks are for sharing. You had it for 2 minutes. Now you can give it to your friend, or I can help you find a new truck. They're modeling the rule, providing clear choices, and setting a boundary. That lets the child make the connection between an action and a social consequence.
Right. And that active guided teaching is completely different from just letting them duke it out, which doesn't really convey any meaning.
None at all. And meaning is also embedded through what the paper calls cultural rituals.
Okay, and that's not just big things like holidays.
No, it also means daily routines. A predictable, loving bedtime routine, for instance, is a cultural ritual. It embeds security and the understanding of temporal order. It grounds the child's whole worldview.
And finally, the condition that's necessary for all this understanding to even take hold: attachment.
Secure attachment is the prerequisite for all of it. A secure relationship fosters the trust a child needs to accept and internalize all these complex social cues, emotional interpretations, and cultural rules. If that relationship is inconsistent or fragile, the bridge of understanding can never feel fully trustworthy.
So we've built the machinery and we've created the meaning. The paper points to one key action that seems to perfectly bridge both the scientific and ceremonial roles: play. And the research makes a crucial distinction here. That is, I think it's really essential for listeners to absorb.
Yes, the difference between independent play and guided play. They're both necessary, but they serve fundamentally different masters.
Independent play being when the child is just entirely in charge, alone with their materials, stacking rings or just running around outside.
Right. Independent play is the engine for internal growth. It builds these crucial intrinsic characteristics: autonomy, self-starting creativity, and critically resilience.
Learning how to recover when the tower falls without an adult immediately intervening.
Exactly. And that directly feeds the scientific, the cognitive side.
And then you have guided play. That's the interactive time when the parent is playing store, building a puzzle, having a conversation while coloring.
And guided play builds external communication and social understanding. It accelerates language because the communication is contextual, and it enhances emotional connection. It's the core mechanism for the ceremonial role. The parent can inject meaning and social rules naturally right into the game.
The research suggests the optimal strategy isn't picking one over the other, but alternating. Why is that specific rhythm-independent discovery, then guided meaning-making, so effective?
Because it creates a cycle. The child uses independent play to experiment, to generate raw cognitive data. They test their boundaries, their ideas. Then they bring that experience to guided play, where the parent helps them integrate those discoveries into a social or emotional framework.
So it trains them for flexible thinking.
Yes, the ability to shift from internal focus to external collaboration. That's a huge component of executive function later in life.
This whole deep dive, it has fundamentally shifted the conversation away from simple nurturing and towards this idea of sophisticated conscious architecture.
Yeah.
You're both a scientist, providing the fuel and framework for neurological growth, and a ceremonial leader, embedding meaning, empathy, and culture.
That is the ultimate conclusion from the Hale Institute. Knowledge isn't just poured into a child. It's co-created through interaction. The potential is seeded genetically, but the active dual role of the parent determines whether that potential blossoms into fully integrated understanding.
It makes the responsibility feel vast, but also incredibly empowering. We talked about how traits like stubbornness are inherited, but highly flexible depending on the environment.
And that fluidity is what determines the path. It really speaks to the ongoing adapting journey of development. The researchers summarize this whole concept with a really powerful philosophical viewpoint for you to consider long after this is over. They state, cognition is destiny in motion.
Destiny in motion. It suggests that while inherited potential sets an initial direction, the constant input from the active architects, the parent, the culture, the environment, it means that the final destination is never truly fixed.
The river is flowing and the bridge is being built day by day.
Interaction by interaction, a profound thought. Thank you for joining us as we explored this intricate architecture of the young mind.
We hope this knowledge helps you see the complex dual role of the parent, both scientific and ceremonial, in an entirely new light.
Until next time.